Welcome back, and in this lecture I want to talk to you about generating random numbers. As you might imagine, generating random numbers is very useful. If you want to write any sort of games, it would be nice if the numbers were generated randomly instead of some pattern. And the function we use to generate a random pattern is rand, okay, R-A-N-D, open bracket, close bracket. It's from the standard library, so you need to include this if you're going to use the random number generator. Now the random number generator is going to generate an it's going to generate an unsigned integer. That's a number between 0 and 65,535. So it's not a big range, but it's useful for a lot of the things we do. So I'm going to build this project. It succeeded. And then I'm going to load it on to the chip. And this little program here waits for me to enter, and then it'll continuously show me the random numbers. So let's open PuTTY. There it is. Let me start. So first random number, next random number, random number, random number, random number, random number, random number. Great. Doesn't seem to be any pattern here. But let me reload this program again. So there it is. Load it again. Let's come back here and hit enter, enter. Hold on. Maybe you can see something here. If I back up, this run of the program has exactly the same run of the numbers that we just used. They're only random if I've run this program once. So that's a bit of a problem. Now, if you read the books, they explain that this isn't actually a problem, is that sometimes you need to know exactly what random numbers you are getting if you want to step through a program and see that the program is operating correctly. But most of the time, we do want some sort of actual random numbers to be producing things. And for that, you need to include another function that's in this library, a function that you only need to call once. It's called srand, and that stands for seed for the random number generator. And you have to put a number in here. So pick a number. 0 is as good as any number. And we can reload it again. We can load up. And we can go back to the program again. Let's see. 1, 2. Okay. And just to make sure, let's reload it again so that we're starting over. Okay. Hold on. That's not random. It's the same sequence of numbers we had before. I knew that. And that's the problem with this, right? This sequence of numbers is based on the seed we did. So if I come here and change the seed from 0 to 1, rebuild it, and then reload it, and look at this. This is different from the previous run, although it's remarkably like one of the earlier runs. So the earlier run was based on the default number being 1. So srandom randomizes it. based on the number that's you give srand. So there's a problem here. And the problem is, if I want a random number, I somehow need a random number in here. If you look at examples in books, one of the ways they do that is by using the current time. Read what time it is, use the time in this function, which every time you start the function should be a different time. And so you should always be having a different seed, and then the sequence of random numbers would be different. But we're on a computer chip, and we don't have any time functions. So we have to work around that. One of the things we have to do is we have to create our own timer. And here's me pasting some code in, right, that starts a timer. It's called timer 0. Right? There's a lot of entries in here that you don't really have to worry about yet. We'll talk about timers again later in more detail. So now this is a timer. Once it's called, internally, it starts a very fast timer going. And so every instruction cycle is going bing, 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 bing. Now this clock, unfortunately, is only of size integer. That's what this thing is saying here, right? So this timer is only going to go from 0 to 65,535. And then it repeats again. So it's always continuously running. But when you create a program like this and create a window like this, it's very unlikely that when the user actually hits the enter button, they're always going to be doing it at the exact microsecond. And this clock is ticking over in microseconds. So very likely that clock will always give you a different random number, a different value of the time, and we can use it in here. To read that time, I use this function, right? It's called read timer 0. It simply reads the current time. That will be some number between 0 and 65,000, whatever. But that's enough difference, that enough for most of our purposes, that this will seem completely random. So let's build this program and run it a few times. Load it up and go. Okay. Well, it's different from the previous times. Load it again. Call it putty. So they're different. Load it again. Again here. Yeah. Right. So we can just scroll up and see that these last guys are not the same sequence. So as far as a user would be concerned, we do have a random number generator. That's all for now.